Experimental design. Essential elements. Science students and scientists carry out a variety of investigative activities. Only some of these activities are strictly considered experiments. Some science activities, such as those that test whether a product does or does not remove a stain, fall into the category of a fair test rather than an experiment. Measurements, such as measuring the melting point of a metal or surveying the heights of all students in the class, are also not considered experiments. To be considered an experiment, the experimenter performs a certain action or varies certain conditions and measures or observes the effect. In this experiment, we will measure the electrical resistance of the pencil lead for different lengths of lead. The factors that change in an experiment are chosen by the experimenter. These factors are called variables. The experimenter purposely changes one variable. This is the independent variable, the IV, or the manipulated variable. A different factor then changes in response to the purposeful change. This is the dependent variable, the DV, or the responding variable. The independent variable is the one that is purposefully changed by the experimenter. You could call it the I change it variable. Here, the independent variable is the length of pencil lead. The variable that may change as a result of purposeful changes made to the independent variable, measured by the experimenter, is called the dependent variable. You could also call it the wait and see variable. Define this variable by how you plan to make measurements in the experiment, remembering your units. Here, the dependent variable is the electrical resistance of the pencil lead. The experimental question inquires about the cause and effect relationship between the independent and dependent variables. Often the experimental question is presented in this form. What is the effect of the IV on the DV? Or, how does changing the IV affect the DV? Remember to avoid experimental questions that can be answered with a yes or a no. Here, an appropriate experimental question is, what is the effect of the length on the electrical resistance of pencil lead? Or, how does changing the length change the electrical resistance of the pencil lead? A hypothesis is a prediction of the relationship between the IV and the DV based on prior knowledge or prior experience. Traditionally, the word hypothesis has been defined as an educated guess. However, it's not simply a guess. You could present your hypothesis in the form, if the IV increases or decreases, then the DV increases or decreases, because, and give reasons based on the prior knowledge or experiences that you hold. For example, here, an appropriate hypothesis might be, as the length of the pencil lead is increased, its resistance will also increase. Constants are all the factors that will remain the same and have a fixed value during the experiment. To be a fair test, some conditions must be kept the same during the experiment. You could call this keep the same. Constants have also been called controlled variables, but note that controlled variables are not the same as a control group. Here, our constants include the type and thickness of the pencil lead and the measuring device that we use. A list of materials and equipment used to conduct the experiment is a necessary component of defining the experiment. A person who has not seen the experiment performed should be able to repeat it with the same materials. Standard materials, such as paper, pencil, calculator, or other things, need not be listed. Here, our materials list includes pencil lead, a board to hold the pencil lead, a ruler or printed grid to measure the length of the pencil lead, and a meter to measure the resistance. A procedure is a sequence of precisely stated steps that describe how an experiment was conducted. Here are some questions that will help guide you as you write the procedure. Is the list of steps complete and sequential? Are all materials and equipment included? Is the procedure written for one level of the IV in such a manner that it could be repeated for the other IV levels? Is the number of repeated trials indicated? Are the different levels of IV indicated? Are safety procedures described? Note that repeated trials are the number of experimental repetitions at each level of the independent variable. The control group is the group that's used as a standard for comparison in the experiment. It may be a no-treatment control or an experimenter-selected control that is defined from among the IV groups. Many physics experiments do not have a control group. Instead, comparisons among groups in the classroom or with a known standard value can be used to validate the results. Make a data table. Begin the data table by setting up vertical columns for the IV, DV, and a derived quantity if appropriate, for example, an average. Draw horizontal rows for each value of the independent variable. Subdivide the columns for the dependent variable to allow space for several trials. Conduct your experiment and enter data into the table. Here is a movie of how the experiment was conducted. A multimeter was used to measure the resistance of the lead. The probes of the multimeter were connected to the pencil lead, and the length of lead between the connectors was increased for each measurement. The data obtained was listed in a data table and plotted on a graph. Only one of our trials is shown in this movie. Here are the values obtained for the 3 trials. The average value of resistance is calculated for each value of our independent variable. We will use this data to generate a graph of the average resistance versus length. Graphs communicate our data in a pictorial form. Typically, you will need to make bar graphs or line graphs, sometimes known as scatter graphs. In this case, we plot the data and draw the best fit line to get a line graph. The conclusion states the purpose, hypothesis, major findings, and a description of in what way the data compare with the hypothesis. It may also include a comparison with other similar experiments and suggestions for further study. In this experiment, our hypothesis was supported by the experiment. The electrical resistance increased with length in a linear manner.